Hello friends, I welcome you in lecture number 5 on graph theory. In previous lecture we have discussed the handshaking theorem, and in this lecture we will see one application of handshaking theorem. So before going for that application, we just recall the handshaking theorem. We have seen in lecture number 4 that if we have an undirected graph, say capital G equal to ordered pair capital V comma E. Suppose this is an undirected graph, then if we take the summation of degrees of vertices of this graph, that is, if we sum the degrees of all vertices of the graph G, then this sum is equal to twice the number of edges in the graph, twice the number of edges in graph G. This result is called handshaking theorem, and using this result we will answer this question which was asked in GTU Summer 2020 exam. A graph G has 15 edges, 3 vertices of degree 4 and remaining vertices of degree 3. Find the number of vertices in graph G. Here we are not given the number of vertices of the graph G, but we are given that there are 15 edges in the graph, there are 3 vertices of degree 4 and remaining vertices of degree 3, and we have to find the number of vertices in the graph. So we can assume that number of vertices, suppose that the number of vertices in graph G are, say, small n, and number of edges are given to be 15. Now we can directly use handshaking theorem. What is handshaking theorem? By handshaking theorem, if we consider sigma degree of all the vertices where V belongs to the vertex set capital V, this is equal to 2 times number of edges. Now we are not given the total number of vertices, but what is given? We have 3 vertices of degree 4, that is, we have 4 plus 4 plus 4. Degree 4 is of 3 vertices, or 3 vertices are of degree 4. So in this summation we have to count, or we have to consider addition of 4 3 times, or instead of writing in this way we can write that 3 into 4. There are 3 vertices of degree 4 and remaining vertices are of degree 3. We have assumed that total vertices are n, so remaining vertices will be n minus 3, because 3 vertices are of degree 4, so total vertices are n, therefore remaining vertices are n minus 3, or there are n minus 3 vertices of degree 4, not 4, of degree 3. It is given that there are 3 vertices of degree 4 and remaining vertices, that is n minus 3 vertices, are of degree 3. That is, we have to write here that 3 plus 3 plus 3 up to n minus 3 times, that is, we can write n minus 3 into 3, and this is equal to 2 times number of edges, and there are 15 edges, so here we write 2 times 15. And then after simplifying and solving this linear equation, we can easily determine the total number of vertices. All we have to understand is that sum of all the degrees equal to twice the number of edges. So it is given that there are 3 vertices of degree 4, so we have to add 4 3 times, that is, we can rewrite this as 3 into 4, and remaining vertices, that is n minus 3 vertices, are of degree 3. That is, we have n minus 3 vertices are of degree 3. So in this summation, we have to consider summation of 3 n minus 3 times, that I have rewritten as 3 into n minus 3. Now this we can simplify. This turns out to be 12 plus 3 into n minus 3, and this is 30. Therefore 3 into n minus 3 equal to 30 minus 12, that is equal to 18. Therefore n minus 3 will be equal to 18 divided by 3, that is 6, and therefore n equal to 6 plus 3, which is 9. So the number of vertices are 9 in the given graph. Therefore the number of vertices equal to 9, or we can use this notation also. The number of vertices in the vertex set is called cardinality of the set V, and that is denoted by this notation. Whenever I am writing in this way, this is called the cardinality of the vertex set V, and that turns out to be 9 here. So this is very easy question. It was asked in GTU Summer 2020 exam. All we have to use is, we are using Handshaking Theorem, which says that the sum of degrees of all vertices in a given graph equal to twice the number of edges in the given graph. We can consider another question related to Handshaking Theorem, which was asked in GTU Summer 2021 exam. Here we have to answer this question: how many nodes or vertices are necessary to construct a graph with exactly 8 edges in which each node is of degree 2. So here also we are asked to find the number of nodes in a graph in which there are 8 edges, that is value of e is 8. We are using small e to denote the number of edges. So we have exactly 8 edges, and every node is of degree 2. So here also we start by assuming that, suppose the number of vertices or number of nodes equal to n, and now we can use Handshaking Theorem. By Handshaking Theorem, we know that sum of degrees of all the vertices is equal to 2 times number of edges. Now here it is given that each node is of degree 2, and we have assumed that there are n vertices. That means degree 2 is added n times 2 plus 2 plus 2, because there are n vertices and each vertex is of degree 2. So we are adding 2n times, that is 2 times, that is equal to 2 into e, and value of e is 8. There are exactly 8 edges. So here I am writing e equal to 8, and this we can write as 2 into n equal to 2 into 8, and this is addition of 2n times, that is 2n, and therefore number of vertices is n equal to 8, or therefore the number of nodes required to construct a graph is equal to 8. So there are 8 nodes necessary to construct a graph with exactly 8 edges in which each node is of degree 2. So sometimes they ask this type of simple questions which are nothing but applications of Handshaking Theorem. All we have to remember is sum of degrees of all the vertices in a graph is equal to twice the number of edges in a given graph. So we will continue with this type of concepts of graph theory in upcoming lectures. Thanks.